Hi, in this video, we want to use R to find stocks that are cheaper, accessible, and those that have enough movement that they would be worth doing, buy low, sell high strategy on like Robinhood. All right, so I got a request and somebody who is, doing Robinhood, and they want to be able to work with just cheaper stocks, and that way it's affordable, and also if they make a mistake, make a bad decision, they're not losing a lot of money. And so what they want to do, they want accessible, cheaper stocks, but they also want ones that move up and down, so that way it's possible for them to buy low, sell high. So think about a stock that doesn't move very much. Well, if you want to do short-term gains where you buy low, sell high, you can't really do that if the stock doesn't move a lot in terms of price. So what we want to do, we want to get some data, identify stocks that are more affordable, cheaper, and then find the ones that have more movements among them, and then proceed as follows. Now, there's another aspect to this. We want to do this without paying to download data. All right, there is tons and tons of stock data available. It's all over the internet. There are tons of ways to go about this. What I'm going to do, I'm going to pick really a convenient data set to work with convenient metrics to work with, rather than going down a rabbit hole to find this. Now, I'm not going to technically use the correct mathematical term for volatility. I'm just going to use like a snapshot of information to identify what would be good candidates to look at. Okay, so what I'm going to do, I'm going to go to NASDAQ, and I'm going to download some data on CSV. And all right, so I was looking around, I found this to be probably the easiest, most convenient way to go about this for this particular problem, was just to go to NASDAQ.com, market activity, stocks, and then hit the download. And here, if you go to the website, there's a bunch of filters on there. If you follow this link exactly as is, you won't have any filters, so you'll be getting a larger data set to work with. All right, so this downloads as a CSV. So then the next thing I do is to download the data. And here I use read.csv to get it. And so here's the file path on my machine. And something I always do when I'm reading in data, I always read in everything as a character, because R is stupid about particular things. So R likes to have things as factors. They screw up things with dates. If it's like a social security number, it'll count it as a number when really that should be treated as a factor or a character. So I just say character, put everything as a character, and I change the things as I want in particular. Now, if we load the names as is with the default settings on read.csv, the column names are not going to be syntactically correct. So I go ahead and I define the column names. These are slightly different than what the default would be from the original data. So change_net and change_% are different than what they would be from the raw data. Now, when it comes to dollar signs, when it comes to percentages, R is stupid. SAS is much better on this front. Okay, so what I need to do, I need to go in, and on last sale, they've got dollar signs. Makes perfect sense to us humans looking at it, but the computer, R, doesn't like dollar signs. So what I have to do, I have to go in, I have to get rid of all of the dollar signs. Now, a dollar sign is a special symbol within the R system, so I'm putting the brackets around it. And every time I see a dollar sign, just get rid of it. I'm using the gsub function for that, and then convert it to a numeric value. Same thing for change percent. There's a percentage. I replace it with nothing. I delete it. Then I convert the result to a numeric. And then there's a few stocks that did not have any change in percent. So I go ahead and just get rid of those. So here, this function gives me true, false, whether there's a missing value. True if it's missing, false if it's not. I want to keep all the ones that are not missing, so I put an exclamation point to filter it out. And then last but not least, for my data prep, I convert volume to numeric because we're going to use this information to double check to make sure that there's enough movement of, or not enough sales of the stock to make it worth our while to even mess with it. All right, so now let's go ahead and visualize percent change and last sale. So I'm going to use ggplot. I'm going to say that last sale is my, so that's, my last sale price. This is going to be my x coordinate. Change in percentage change is going to be my y coordinate. My color and the size of the dot is going to correspond to the volume, but I'm going to put it on the log scale because some of the stocks have much greater volume than others. So when you have like a crazy dispersion of your data and it's like it's uneven, go ahead and hit with log. Anytime you're dealing with money, the logarithm is probably the transform you want to use. A good second choice is square root transform, but that's usually better for counts. Well, volume would be a count also, but here log worked out the first time I tried, so it's good. Now here you'll notice that there is one that is selling for a crazy large amount there for their last amount. This might be Amazon, so I don't know which one it is, don't really care. But it's so big that for this purpose, it's throwing everything off. And so this is, this plot is meaningless. I can't figure anything out from it. So what I'm going to do, I'm going to filter out the data so that I'm only looking at the cheaper stocks. I'm only going to look at the stocks that are less than or equal to $10 on their last sale price. Okay. So now I've reduced it down to, so I call it m_small. And now I do the same plot, but this time I'm only doing it with the cheaper stocks. Okay, so now I've got something to look at. And so we can see that, it's if I look at the percentage change, that, the most are just hovering pretty close to zero. I don't have a lot of wild, crazy fluctuations going on. Now, as I look through this, I can just kind of see that everything's clumped up there. I can use the lighter colored ones are the ones that had greater volume, and the darker ones are the ones that had lesser volume. And also the darker ones you'll notice are smaller. Okay, well, so I've got the price right, but I really, I have ones that, in terms of change of price, it's relatively, a lot of them are close to zero. So let's go ahead and filter some out. All right, so what I'm going to do, I want to filter it down to an even smaller data set. Now here, this is, if I was doing this with like my own money and my own analysis, I was going to execute it, I would play around with this a lot more than what I did. I just picked, since I'm just looking for greater volatility for this video, I just picked I want the top 1% of volatile stocks from my n_small. So what I'm going to do, I'm going to get the absolute value of the change in the percentage change. I call that V. Now I'm going to grab the ones that are in the largest 1%. So I'm just trying to look for the most volatile. And I'm going to call that new data set m_look, because these are the ones I'm going to look at. Okay. And now I do exactly the same plot I did before, except I'm going to put on some labels so I can see what the names are if they start piquing my interest. And so now, when I do the scatter plot, we can see that everything that was close to zero now is just gone. It's removed. I don't have this overlap business going on. All right. And I can see the names of each of these. And I can also, use the color and the size to get an idea of which ones had more volume in terms of trading. So like here, this BRLIR, so BRLIR, this one had very little in terms of volume, while this AHPI had a lot more. And so now I can look at, this is just looking at the last of them, the ones with the greatest percent change. And so we can see this ERYP had the greatest percent change of about 55%. That's quite a bit. Something interesting probably going on in that company. All right, so now this is not enough just for me to like execute on. I want to get a more complete representation so I completely understand what's going on before I actually start committing to this. So what I'm going to do, I'm actually going to go in, I'm going to get the last year of data using batch get symbols from the batch get symbols package. I'm grabbing the symbols from m_look. I'm looking at only the ones that had price was less than or equal to 10, and they had the greatest volatility in the data set. Now, I'm only going to accept ones that have 3/4 of useful data. If I get less than 3/4 of useful data, I'm just going to throw it out because that's an indication to me that the stock is not as reliable. Like maybe it doesn't have enough of a history or it's coming off the stock market. I don't know. I just want ones that have more of established history so that way I'm not wasting my time. And so we can see that a whole bunch of these don't work out. So here, like this one, this BRLIR, we got 0% of the data. Now here I'm only using Yahoo. And now there might be, if I was to go to Google or Fred or another source, I might be able to get the data that way. But here, I'm basically screening things out. And my attitude is if I can't pull it pretty quickly, it's probably not the one I want to go with. And so, we can scroll down. Like here we got 7% of valid data, but that's just not enough. So, we'll notice here that this one, we got 92%. That's above 3/4, so that's good enough for the criteria that I set. All right, so now let's actually plot. So you'll notice that out of all of the ones I had previously, I actually, not very many, had enough data for me to accept and go with. So we have, what, 12 different stocks that have been identified as being cheaper and having, at least in a snapshot one-day analysis, had greater volatility. All right, and so at this point, if I was going to be working on this, I would start like digging in and studying these individual companies more precisely, more completely, so that way I can make a good, solid choice. Well, that's all I've got for you. Take care and goodbye.